Okay, we are going to look at sorry. We are going to look at sorry. I was just trying to stop the fan so I can fix the sound. Let's look at. We continue with analytical geometry. There are small things that we have to revise, and sometimes students they forget the small things. When it comes to the test, they fail. Or they mix it most of the time. They can mix this thing with a circle. Okay, like they can put something like this, and then there is we have this, and then we have a line that goes like this, and it's the center where we have another line goes there. So, or another line maybe pass over there. You see, and then you have to prove these two lines are parallel, and then this is a tangent. The tangent is perpendicular to the radius. Okay, so and they can say that okay, prove that the radius of a circle is a perpendicular. This is a tangent. Okay, they say prove that this line is a tangent. Okay, so we know that the radius is perpendicular to the tangent. Okay, so to prove it, you need to know the perpendicular lines. Okay, when lines are perpendicular, how do you know this line are perpendicular and these two lines are parallel? Very simple. Two lines are parallel when the gradient, or let's say this is line 1, this is line 2, so the gradient of line 1 should be equal to the gradient of line 2. So when in this case you say that the two lines are what? Parallel. Okay, then we have two lines are perpendicular. When the two lines are perpendicular means what? When you take, this is a line 1, alright, and this is a line 2. So when you take this, the gradient of this line 1, you multiply by the gradient of line 2, the answer should be -1. So two lines are perpendicular. When you multiply their gradient, the answer should be equal to -1. Alright. For example, I'll give you an example now. And the two lines perpendicular makes the angle of what? 90 degrees. There we go. We'll have here now, for example, of two lines perpendicular. For example, this line, alright, and this one, these two lines are perpendicular. Remember the equation of a straight line. Alright, so the gradient of the first one, m is equal to 2, and this gradient also m equal to 2. So this is m1, m2. So both are equal, meaning that the two lines are parallel. Alright, now the lines are perpendicular. We have, for example, this straight line. We have another straight line like this. So you have to know, when you have a straight line and there is nothing that is written here, this means that the gradient is equal to 1. Okay, and the here means that the gradient is equal to -1/2. So now to prove that this is a perpendicular, you need to get m1 multiply by m2 to see if it's going to give you minus 1. Then we have 1 multiply by m2 minus 1 over 2. And then we see that the answer is minus 1. So this proves that the two lines are perpendicular. So this is very important too, because you come across all the time in a question that you need to prove that the two lines are perpendicular. Okay, so they can ask you a question, for example, where they give you, they say find the straight line where you have a straight line like 3 over 2 and the x plus 1, 3 or 2x plus 1, and then they said determine the straight line passing by a point P 1 to 1, for example. Okay, or let's say 1, let's say 2. Okay, minus 1 and 2. Now this is equation. They say determine the equation of a straight line passing through perpendicular to the above equation, or the above equation of a straight line. Okay, now let me do this to a straight line y equal to 2. Okay, all right, so what we have to know here, we want to find the equation of a straight line passing by the point P. So the equation of a straight line will be mx plus c, and the passing to, all right, so what we don't know is the gradient of this equation. Let me call it the gradient prime. Okay, so now it says that this equation is perpendicular to this straight line, should be perpendicular to the new straight line passing by the point P. Okay, so we need to find the gradient. So what we do first, as they are perpendicular, what you do, you find first the first gradient. Remember, this is the gradient, 3 over 2. All right, now to find the second gradient which of this equation, which is perpendicular, you say 3 over 2 multiply the first gradient of this equation, multiply by this gradient, which is m prime. It should be equal to minus 1. Okay, so if you multiply both sides by you multiply 3 over 2, so you reverse, so we cancel. So 3 over 2 times 2 over 3 will be cancelled out. Okay, this will be cancelled with this, and this will be cancelled with this, so this will be m prime. And then minus 2 times minus 1 times 2, we have minus 2 over 3. So once you are done, you can see here we have minus 2 over 3. Now let's find the equation of a circle, of a straight line. That will be easy. Okay, so we'll have y is equal to 2, x m is equal to minus 2 over 3, and our x is what? Minus 1, okay, plus c. So instead of x we put minus 1, instead of m we put minus 2. So we have this, when you multiply here will be plus 2 over 3, you transpose will be 3 minus, okay, because when you transpose will change the sign. So minus times minus will be positive, you transpose will change the sign. So if you continue here, you solve this will be 6 minus 2, so c will be equal to 4 over 3. So therefore the equation of a straight line which is a perpendicular to this equation will be, our gradient is what? We replace here by gradient, which is minus 2 over 3 x, and then c will be 4 over 3. Alright, so now that's what we can see about this. Now if they say, if they remove this, let's see now. I want us to keep the equation of a perpendicular, okay? So this is the equation. Here we have this equation of a circle, minus 2 over 3 x plus 4 over 3. So these two equations are what? Perpendicular. Okay. So if now we have determined the equation, determine the straight line, or the straight line, I didn't write line, sorry, the straight line passing through by minus 1, by the point P minus 1, the coordinate minus 1 and 2, if they say parallel to the straight line, y equal to 3 over 2 x plus c. So what is the gradient of this? M is equal to 3 over 2. Alright? M is equal to 3 over 2. Now let's go here now. Alright? Because they are parallel, let's find the equation of each parallel. Mx plus c. What is the y value will be 2, the m will be 3 over 2, the x will be minus 1 or minus 1 instead of x, then we have a c. So when you multiply here will be minus 3 over 2, you transpose will be plus 3 over 2 equal to c. So c will give you 7 over 2. Therefore, the equation of a straight line m is still the same gradient, which is 3 over 2 x plus c, which is 7 over 2. So the line which is a parallel to this straight line, alright, look at here. So if we have in this case, what we will say, this one, 3 over 2 x plus 1, it's parallel to what? Equation 3 over 2 x plus 7 over 2. Why? We can see the gradient m1 equal to m2, which is a 3 over 2. Then we see the equation 3 over 2 x plus 1, it's perpendicular to y equal to minus 2 over 3 x plus 4 over 3. So the two perpendicular lines, the gradient of this is what, 3 over 2, and the gradient of this equation is minus 2 over 3. So if you multiply them, you have a 3 over 2 multiplied by minus 2 over 3. So 3 divided by 3 is gone because there is multiplication. So you cancel this. So here we're going to be minus 1. So it's proven. So thank you. So we have here today we learn about the parallel lines and the perpendicular line. Thank you.